this will be the end of section 8.1. I guess it's part 3. And these problems have systems of equations that have 3 equations and 3 unknowns. And the instructions are real similar. It just says solve the system of equations. It doesn't indicate to use the elimination method or the substitution method. Unfortunately, to solve these, we're going to wind up using the elimination method 3 times and the substitution method once, I guess. So they're going to be monstrous problems. And then it says if a system has no solutions, say it has no solutions, and that it's inconsistent. I'm probably just going to say it has no solutions. And then it says if a system has infinitely many solutions, just say the system has infinitely many solutions rather than doing that set builder notation that we did for the last few problems in my part 2 of my video. So we're not going to worry about the set builder notation. Real quickly, if the rules are the same for this set of more complex problems, if all the letters drop out and you have a false statement, so if during my algebra, if all the letters drop out, if there's a false statement, that's when there's no solution. Just like we did in the first 2 videos. If all the letters dropped out and we were left with a statement like 7 equal to 14 or 0 equal to 11, that's going to be a no solution. So when it says up here, if the system has no solution, just say it is inconsistent. We can say no solution or inconsistent if all the letters drop out and a false statement is staring at us. If all the letters drop out and you're left with a true statement, like 0 equal to 0 or 9 equal to 9, instead of taking the time to write our answer in set builder notation, we're just going to say there's infinitely many solutions. So when we're solving the 3 equations with 3 unknowns, it's going to take the elimination method 3 times to finish up the problems. And we'll just get going here. So in general, if I gave you this system of equations, I wouldn't expect you to know how to solve it. So I wrote up some instructions and I'll solve a couple problems to help us get through this. So step 1, when we have 3 equations and 3 unknowns, is to pick an equation and pair it with the other 2. The first step for your problem 37, you're going to pick the middle equation and pair it with the other 2 because that's what my hint was. This isn't the only way to solve this, but I think this is the easiest way to get started. So when I flash up my problem 38, the very first thing I want to do is pick an equation and pair it with the other 2. I said to pair the middle equation with the other 2. So that's how I'm going to get started for problem 38. I'm going to take the middle equation, negative x plus 2y plus 2z equals to negative 11. Pair it with the top equation, 3x minus 2y plus z equals to 15. And I'm going to pair the middle equation with the bottom equation. Done with step 1. Pick an equation, pair it with the other 2. This creates 2 pairs of equations. Pick a letter to drop out. This parenthetical comment that I'm erasing that says don't drop out the z, that has to, if you drop out the z and if a problem has infinitely many solutions, if you want to write the solutions with the set builder notation, it doesn't really help you get the right set builder notation. So we're going to pick a letter to drop out. We can drop out any letter and then drop out the same letter from each pair. This will create 2 equations with 2 unknowns. I'm going to move on and do my step 2 now. I decided I'm going to drop out the y's. The reason I'm going to drop out the y's is because they're easy to drop out. For the first pair of equations, if I just add the equations together, the y's are going to drop out because they have the same numbers in front of them with opposite signs. So I'm going to just combine these 2 rows together. take the negative 1x that's implied in the top equation and the 3x in the bottom, combine them, they have opposite signs, so I subtract and get a positive 2x. Cancel the y's, take the 2z in the top equation, the 1z that's implied in the bottom equation, combine those together, add because they have the same signs, and get 3z. To the right of the equal sign, the 15 and the 11 have opposite signs, so I subtract and get a positive 4. Since I dropped the y's out in this pair, I need to drop the y's out in this pair. The y in the bottom equation has a minus 1 in front of it. What I'm going to do is I'm going to make the bottom have a minus 2y, and I leave the top with the positive 2y. That will make the y's cancel. To get the bottom to have a minus 2y, I just need to multiply it by positive 2. I'm going to leave the top equation the same, although maybe I'll sneak a 1 in front of that minus x just to make the next step easier. So top equation stays, at negative x plus 2y plus 2z equals to minus 11. Now for the bottom, I'm going to go 2 times x and get 2x, 2 times minus 1y and get minus 2y, 2 times minus 4z and get minus 8z, 2 times 14 and get 28. Combine these together, negative 1x plus 2x is positive 1x. 2y's are opposite, so they cancel. The z's have opposite signs, so I subtract and get a minus 6z. The numbers have opposite signs, so I subtract and get a positive 17. Done with step 2. I picked a letter to drop out. I dropped the same letter from each pair. Moving on to step 3, take the 2 equations created in the last step and solve them using the elimination method. This will give answers for 2 of the 3 variables. So I'm going to take these 2 equations, 2x plus 3z equal to 4, and put that with the bottom equation, which is kind of 1x minus 6z equals to 17. This is going to be my third elimination method. I've done the elimination method twice. I need to do it 3 times. What I'm going to do for this set is I'm going to make the top have a 6z, and I'll leave the bottom with the negative 6z, and I'll drop out the z's. So to do that, I'm going to multiply the top by 2. It's going to give me 2 times 2x is 4x, 2 times 3z is plus 6z, 2 times 2 is 8, 2 times 4 is 8, and make the bottom 1x minus 6z equals 17. This is going to give me 5x equals to 25. The z's are going to cancel. I'm going to divide by 5, and get for an answer x equal to 5. When I look at my problem, I actually wrote the answer down. I wrote it like we did right at the beginning as an ordered triple. Here's the x equal 5 part of the answer. Supposed to get in this step answers for 2 of the 3. I have answers for 1 of the 3. Now I need to get the answer for the z. I'm going to solve for z. By picking this equation that has a z that's easy to solve for. So the 2x plus 3z equal to 4. I'm going to use that and plug 5 in for x and go 2 times 5 plus 3z equals to 4. This will give me 10 plus 3z equals to 4. I'm going to minus 10 from both sides and get 3z equals to minus 6. And then divide by 3. That's going to give me z equals to minus 2. That's that part of my answer. And now I'm done with step 3. I took the 2 equations created in step 2, solved them by the elimination method, got answers for 2 of the 3 letters. Now I'm going to substitute in my last step the answers from this last step into any one of the original equations that I think is easiest and solve for the remaining variable. The remaining variable is y. So I need to pick one of the original equations, so I'm done with my third step. I need to solve for y. I'm going to pick that equation to solve for y. To solve for y, I'm going to use the equation negative x plus 2y plus 2z equals negative 11. And in for x, I'm going to plug 5, so I'm going to get negative and then a 5. I'm solving for y, so I don't have anything to plug in for y. And then for z, I'm going to plug in negative 2. That will give me negative 5 plus 2y plus 2 times negative 2 equals to negative 11. This simplifies to be negative 5 plus 2y minus 4 equals negative 11. The minus 5 and the minus 4 have the same sign, so I'm going to add those and keep them negative. That will give me 2y minus 9 equals minus 11. I'm going to add 9 to both sides. That will give me 2y equals negative 2. And then divide by 2, divide by 2. Here are the y's, 2's cancel, I'm left with a y, and then negative 2 divided by 2 is negative 1. That gives me y equal to negative 1, which is perfectly in my answer. So my answer for each letter goes as an ordered triple as opposed to an ordered pair, x then y then z. I'll check on the next one because I already took 12 minutes to do this one and help you get started with your problem 37. So to get started with 37, it says pair the middle with the other two. So your first thing you're going to do is take the middle equation, 2x minus y plus z equal to 21. Pair it with the top equation, negative x plus 2y minus z equals negative 17. And then pair the middle equation, 2x minus y plus z equals to 21, with the bottom equation, 3x plus 2y plus z equals to 19. That's done with step 1. Picked an equation, paired it with the other two. Now we need to pick a letter to drop out and drop it out. I suggested to drop out the y's. So for this set over here, you're probably going to make the top have a minus 2y and leave the bottom with a positive 2y to get started. I'd probably do the same thing for this set. I'm going to make the top have a minus 2y, and I'm going to leave the bottom with a plus 2y. So you're going to do the elimination method here to drop out the y's, elimination method here to drop out the y's. Once you do that, you'll take the answers from these steps, move on to step 3. So do the elimination method twice in step 2. Then take the answers, stack them on top of each other, and use the elimination method your third and final time to get answers for 2 of the 3 letters. I'm going to move on. Heck, let me do your problem 39 as opposed to my 40. So if you're not ready to do 39 by yourself, watch me do it. If you're ready, do it and see how it goes. So my first step in 39 is to pair the middle equation with the other two and drop out the x's. So I'm going to take the middle equation, which is negative x plus y plus 2z equals to 7. Pair it with the top equation, 2x plus y minus 5z equals negative 11. Wow. And then the middle with the bottom, negative x plus y plus 2z equals to 7. Pair it with the bottom. Done with step 1. I picked an equation, paired it with the other two. I've already picked my letter to drop out. Now I need to drop that letter out. So I picked out to drop the x's. To drop out the x's here, I'm going to make the top have a negative 2x, and I'm going to leave the bottom with a positive 2x. To make the top have that negative 2x, I'm going to multiply it by 2. Because when I do this multiplication, I'm going to get 2 times negative 1x is the negative 2x that I need. 2 times y is positive 2y. 2 times 2z is positive 4z. 2 times 7 is positive 14. I'm going to leave the bottom row 2x plus, I'll emphasize, 1y minus 5z equals negative 11. Stack those on top of each other. Cancel the x's, then 2y plus 1y is 3y, 4z minus 5z is negative 1z, 14 minus 11 is positive 3. For this second pair, I want to drop out the x's, and they're already ready to drop out. They have the same number, 1, with opposite signs. So I'm just going to add these together, cancel the x's. 1y minus 3y is negative 2y. 2z plus 1z is positive 3z. 7 minus 2 is 5. Done with step 2. I picked a letter to drop out from those sets of equations, dropped it out. Now I have 2 equations and 2 unknowns. On to step 3, taking the 2 equations created in step 2, stack them and solve using the elimination method to get answers for 2 of the 3 letters. So on to step 2 now. I'm going to take the 3y minus 1z equals to 3 and the minus 2y plus 3z equal to 5, stack them and use the elimination method. I'm going to drop out the z's. I'm going to make the top have a minus 3z, and I'm going to leave the bottom with a plus 3z. And that's going to cause the z's to cancel out, which is what I'm trying to do here. So multiply the top by 3. 3 times 3y is 9y. 3 times minus 1z is minus 3z. 3 times 3 is 9. I'm going to leave the bottom minus 2y plus 3z equal to 5. Now I'll combine these. 9y minus 2y is 7y. Force the z's to cancel. 9 plus 5 is 14. Divide by 7, divide by 7, and get y equal to 2. On this step, I'm supposed to get answers for 2 of the 3 letters. Now I'm going to get the answer for z. I'm going to use that equation because it has a positive z. So as I go to solve for z in this step, I'm only looking at the pair of equations here. And I'm going to take the equation minus 2y plus 3z equal to 5 and plug in 2 for y and get minus 2 times 2 plus 3z equals to 5. That's going to give me minus 4 plus 3z equals to 5. I'm going to plus 4 from both sides and get 3z equals to 9. And then divide by 3 and get z equal to 3. Done with step 3. I took the 2 equations created in step 2, used the elimination method, got answers for 2 of the 3 letters. Now I move on to my last step. I'm going to substitute the answers that I just got into one of the original equations, solve for the other variable. So I need to solve for x. So I need to take one of the equations in the original problem that has an x. I'm going to use this bottom one because that's such a nice x. So as I go to solve for x, and my last step, I'm going to use the equation x minus 3y plus z equals to negative 2. Because of the top equations, it has the easiest version of the x. And I'm going to substitute y equal to 2 and z equal to 3 and go x minus 3 times 2 plus 3 for z equals to negative 2. That will give me x minus 6 plus 3 equals to negative 2. That gives me x minus 3 equal to negative 2. And I'll add 3 to both sides and get x equal to 1. I claim my answer is x equal to 1, y equal to 2, z equal to 3. And I'm going to take the time to check this because we should check every answer unless I took the time to write the answer down for you. So the answer that I came up with for problem 39 is x equal to 1, y equal to 2, z equal to 3. I'm going to check in this top one and go 2 times 1 plus 2 minus 5 times 3 and make sure that that equals to minus 11 using my calculator because I don't want to do this by hand. So by my calculator, going 2 parentheses 1 plus 2 minus 5 parentheses 3, and that gives me negative 11, and that matches the right side, so I know it checks in the top equation. Move on to the bottom equation and check. I'm going to go negative and then an x for 1 plus and then a y for 2 plus 2z, which is 2 times 3, and that's supposed to equal 7. I just wrote it in red to separate it from the line above it. And now checking negative 1 plus 2 parentheses 3 and that gives me 7 equal to 7, so it checks in the second equation. Move on and check the bottom equation by going 1 for x, minus 3, and then 2 for y, plus, and then 3 for z, and make sure that that equals to negative 2. So real quickly, 1 minus 3 parentheses 2 plus 3, and that gives me negative 2 equals negative 2. The only way you know your answer is correct is if you go to every single equation for each x, each y, and each z, plug that number in. You need to get 3 sets of true equations for it to be a successful answer. Your 41 will be next. I don't know if you're ready for that yet. If you want to start 41, I didn't tell you how to start. I might, because the x's look easy to drop out. These two equations I could just add together to drop out the x's. These two equations, it wouldn't be that hard to make this have a negative 2x to cancel with that 2x. My instinct would be to pair the bottom with the other two and drop out the x's. You certainly, if it was your instinct to drop out the z's, these two equations you could add together and drop out the z's, which would be easy to do. And this equation and that equation, you can make that have a negative 5z to cancel that positive 5z. The other easy way to start is to pair the top with the other two and drop out the z's. They both will give the same answers. The work will look completely different, but the answers will be the same. So I'm not going to flash 41 back up here. If you're not ready to do it, watch me do 42. And nicely, I have an answer here, so I won't do the checking part because it takes a long time to check. I wrote to start any way you like. I'm going to drop out the x's specifically because the negative x will make it easy to cancel the x's in the other equations. So I'm going to pick an equation, pair it with the other two. I'm going to pair the top equation with the bottom two. So I'm going to take the top equation, negative x plus y plus 2z equal to 1, and pair it with the middle equation, and pair it with the bottom equation. Done with my first step. I'm going to pick a letter to drop out. I already picked the x, and I'm going to drop that from each pair. It's going to give me two equations with two unknowns. So for this one, I'm going to make the top have a negative 2x, and I'm going to leave the bottom with the positive 2x and drop out my x's. So I'm going to multiply the top by 2. I'm going to go 2 times minus x, that's minus 2x. 2 times y is plus 2y. 2 times 2z is plus 4z, and 2 times 1 is 2. I'm going to leave the 2x plus 3y plus, I'll emphasize, 1z equal to negative 2 alone. Combine. X's are going to cancel, which I'm forcing to do. 2y plus 3y is 5y. 4z plus 1z is 5z. 2 plus negative 2 is 0. Done with that set. Moving over to this set, I'm going to make the top have a negative 5x and leave the bottom with a positive 5x. I have to drop the same letter from both. If I drop an x from one and a y from another, it's not going to work. To make the top have a negative 5x, I'm going to multiply it by 5. I'm going to go 5 times negative x is negative 5x. 5 times positive y is positive 5y. 5 times 2z is plus 10z. And then 5 times 1 gives me a 5. I'm going to leave the bottom equation, positive 5x plus 4y plus 2z equals to 4. Combine. X is canceled. That's what I'm forcing it to happen. 5y plus 4y is 9y. 10z plus 2z is 12z. 5 plus 4 is 9. Done with step 2. On to step 3. Take the two equations that I just created, solve doing elimination method to get answers for 2 of the 3 letters. So on my next step, I'm going to put a 5y plus 5z equal to 0 and a 9y plus 12z equal to 9 together. It's not easy to do here. The y's have 5s and 9s in front of them. The least common multiple between 5 and 9 is 45. To drop out the y's, I need to get a positive and negative 45 in front of the y's. The numbers in front of the z's are 5 and 12. The least common multiple between 5 and 12 is 60. To drop out the z's, I need to make one negative 60 and the other positive 60. Since 45 is smaller, I'm going to drop out the y's. I'm going to make the top have a negative 45y and the bottom have a positive 45y, which is the least common multiple between 5 and 9. So for the top, I'm going to multiply by negative 9. Go negative 9 times 5 is negative 45, and I'll keep that y. Negative 9 times positive 5 gives me negative 45z. And then negative 9 times 0 gives me 0. So that should say negative 45y minus 45z equal to 0. For the bottom, to get the positive 45y, I'm going to multiply by 5. Go 5 times 9y is 45y. 5 times 12z is 60z. 5 times 9 is 45. Ready to combine to drop out the y's. Y's drop out. Negative 45z plus 60z is positive 15z. 0 plus 45 is 0 is 45. Divide by 15, divide by 15. This is going to give me z equal to 3, which is that part of my answer. Not done with this step yet. I need to get an answer for y. I'm going to use the equation 5. Oh gosh, I don't like work with a 0. I'm going to use, I could work with a 0. I'm going to use the equation 5y plus 5z equal to 0 because it has the smaller numbers, and plug 3 in for z. Would give me 5y plus 5 times 3 equal to 0. That's going to give me 5y plus 15 equals to 0, and then minus 15 minus 15. That will give me 5y equals minus 15, and then divide by 5, divide by 5. That will give me y equal to negative 3, because negative 15 over 5 is negative 3. That's that part of the answer. Done with step 2, on to step 3. Substitute the answers from part 3 into any one of the original equations. Solve for the remaining variable, which is going to be x. I can pick any of the original equations. I don't like negatives in front of the letters I'm solving for. I'm going to use that on my last step to get my x equal to 2, and I'll shove it up here. So I'm going to solve for x. I'm going to use the equation 2x plus 3y minus z equals negative 2, and plug in 3 for z and negative 3 for y. And when I do this, I'm going to get 2x plus 3 times negative 3 for y minus 3 for z equals to negative 2. So give me 2x minus 9 minus 3 equals negative 2. I'm worried here that I have a mistake going on. Y is negative 3. I don't see a mistake just staring at. Oh, yes, I do see a mistake. This I wrote a minus right here. This is supposed to be a plus. So if you can't copy the problem down right, you can't get the right answer, and I do that all the time. So when I copy this problem, I wrote a minus in front of the z. It should be a plus in front of the z. So on that line, the minus in front of the z should be a plus. That minus should be a plus. Now I get 2x plus 3 times negative 3, which is 2x minus 9, plus z, which is plus 3, equals to negative 2. This will give me 2x minus 6 equals negative 2, because those numbers have opposite signs, so I subtract them and take the sign of the larger. Now I'm going to add 6 to both sides. On the left side, the 6's will cancel. I'll be left with a 2x. On the right-hand side, the numbers have opposite signs, so I subtract, take the sign of the larger. And now I'm just going to divide by 2, and get x equal to 2, which is the last part of my answer, which I won't check because it takes so long to check. All right, so give 43 a go. And my best guess would be to pair, if you want to, a hint, the middle with the other two and drop the z's, because if you look at the z in the middle, it's negative. The z's in the other ones are positives. Negatives and positives are nice. I like opposite signs. And the bottom two equations, if you add them together, the z's will drop. To get the z's to drop from the top in the middle, you can just multiply the top by 2 to get an 8z. So that's probably a really nice way to solve that. Problem 44 says there's no solution, which means that at some point in the algebra, all the letters will drop out. And a false statement will remain. Anytime we're solving these problems, if all the letters drop out, we're done doing our algebra. If a true statement remains, there's infinitely many solutions. And if a false statement remains, like 0 equal to 8 or 5 equal to 23, we're going to write no solution. So at some point, when I do my algebra, all the letters are going to drop out. So step 1, pick an equation, pair it with the other two. I said pair the middle with the other two, so I'm going to do that. I'm going to take the middle, negative x plus 2y plus z equal to 5. That's the middle equation. I'm going to pair it with the top, 2x minus 3y minus z equal to 0. And I'm going to take that middle equation, negative x plus 2y plus z equals to 5, pair it with the bottom, 3x minus 4y minus z equal to 1. So done with step 1. Step 2, pick a letter to drop out. Drop that same letter from each pair. I said I'm going to drop out the z's because the z's are super easy to drop out. The first set of equations I can just combine, and the z's are ready to cancel out. So I'm going to combine them. Negative 1x plus 2x is positive 1x. 2y minus 3y is negative 1y. Z's cancel. 5 plus 0 is 5. Second set, z's ready to cancel out because they have the same number, 1 with opposite signs in front of them. So just add them together, the z's will drop out. Negative 1x plus 3x is positive 2x. 2y minus 4y is negative 2y. Z's cancel. 5 plus 1 is 6. Alright, now done with step 2, on to step 3. Take the two equations created in the last step, solve them using the elimination method. So take these two equations. X minus 1y equals 5. 2x minus 2y equal to 6. I'm going to drop out a letter. I'm going to make the top have a positive 2y, and I'm going to leave the bottom with a negative 2y to drop out the y. So I'm going to multiply the top by 2. I'm going to go 2 times x and get 2x, and then 2 times minus 1y, get minus 2y, and then 2 times 5 and get 10. Leave the bottom one. Whoa. I needed to make it have a positive 2y. Should have multiplied by negative 2 because I didn't get a positive 2y. When I started to write down my next equation, 2x minus 2y equal to 6, the y's weren't ready to cancel because I messed up here. I should have multiplied by negative 2 and go negative 2 times x and get a negative 2x. Negative 2 times negative 1y and get a positive 2y. Negative 2 times negative 5 and get a negative 10. Now the y's are ready to cancel. The y's wouldn't have canceled when they had the same signs. They have to have opposite signs. Now, negative 2x, positive 2x, cancel. Positive 2y, negative 2y, cancel. So I get a 0 on the left-hand side. The right-hand side, negative 10 and positive 6 gives me a negative 4. All the letters dropped out. I have a false statement. I'm done. For my answer, I can write no solution, and that's kind of what I prefer. Most text, or a lot of text, when the problem has no solution, will say inconsistent for the answer. So you can do either say no solution or say inconsistent. My best guess is that your problem 45 is going to have no solution. I gave you a hint on how to start. Pair the bottom equation with the other two, and then drop out the x's. My 46 also says no solution. Let me do another one of your problems. So I'm not going to do 46. In place of 46, I'm going to do 47, just so you can have one of your homework problems so you can check completely right without going to the solutions manual. So step 1, pair the bottom of the equation with the other two. So take the bottom equation, x minus 4y plus z equal to 1. Pair it with the top, 2x plus y minus z equals to negative 2. And take the bottom, x minus 4y plus z equals to negative 9. Pair it with the middle, x plus 2y minus z equal to negative 9. This right here should be a 1. For some reason, it gets hard for me to copy problems down correctly, which is a horrible, horrible crutch. This equation here, 2x plus y minus z equal to negative 2, I didn't write the negative. This one, I started writing the wrong number. So x minus 4y plus z equal to 1, x plus 2y minus z equal to negative 9. Just checking to make sure I wrote everything down right. Done with step 1, I'm going to drop out the z's. For both of these, the z's are ready to go, just like they were ready to go for mine. So I'm just going to add these together. For your left pair here, 1x plus 2x is 3x. Negative 4y plus 1y is minus 3y. Z's cancel. 1 minus 2 is negative 1. Next set, 1x plus 1x is 2x. Negative 4y and positive 2y is negative 2y. 1 and negative 9 combine to be a negative 8. So I'm going to stack these on top of each other now. Get 2x minus 2y equals negative 8 on top of 3x minus 3y equals negative 1. I'm going to make the top have a negative 6x and the bottom have a positive 6x. 6 is the least common multiple between 2 and 3. That's why I picked a 6. Multiply the top by negative 3, the bottom by 2. When I multiply the top by negative 3, I go negative 3 times 2x and get negative 6x. Negative 3 times minus 2y and get positive 6y. Negative 3 times negative 8 and get positive 24. Bottom by 2. 2 times 3x is positive 6x. 2 times minus 3y is minus 6y. 2 times minus 1 is minus 2. Combine, x's cancel, y's cancel, so I get a 0 on the left-hand side. On the right-hand side, I get positive 22. All the letters canceled, so I'm done. And for my answer, because that's a false statement as opposed to a true statement, I can say no solution, or if I prefer, I can say inconsistent. These are the best kinds of problems because you don't have to go through all the steps. Once all the letters drop out, you're done with your algebra. All right, so I'll do 48, and all the letters are going to drop out, and I'm going to be left with a true statement because the answer is infinite, or I could have said the answer is that there is infinitely many solutions. And immediately, I know that all the letters are going to drop out at some point. And a true statement will remain. So, my hint was to take the top equation, pair it with the other two. So I'm going to take the top equation, 2x minus 3y minus z equal to 0. Pair it with the middle. And then take that top equation, 2x minus 3y minus z equal to 0, and pair it with the bottom. Drop out the z's. For this set over here, I'm going to make the top have a 2z by multiplying everything by 2. I'm going to go 2 times 2x is 4x, 2 times minus 3y is minus 6y, 2 times minus z is minus 2z, 2 times 0 is 0. Leave the bottom 3x plus 2y plus 2z equals to 2. Add these together. 4x plus 3x is 7x. Negative 6y plus 2y is minus 4y. Z's cancel, and 0 plus 2 is 2. For this set to drop out the z's, I'm going to make the top have a minus 3z, and I'm going to leave the bottom with the positive 3z. To do that, I'm going to multiply the top by 3. Go 3 times 2x is 6x. 3 times minus 3y is minus 9y. 3 times minus z is minus 3z. 3 times 0 is 0. Leave the bottom one, x plus 5y plus 3z equals to 2. Snuck a 1 in front of that x because it helps me out. This is going to give me 7x minus 4y. Whoa. Z's cancel out, equals to 2. I have two identical equations. Absolutely, that's going to be in infinitely many solutions. Next step, stack these on top of each other. Solve using the elimination method, my third elimination method. What I'm going to do is I'm going to multiply the top equation by negative 1, and it's going to cause both letters to cancel. When I multiply the top by negative 1, I go negative 1 times 7x is negative 7x. Negative 1 times negative 4y is positive 4y. Negative 1 times positive 2 is negative 2. I'm going to leave the bottom equation, 7x minus 4y equal to 2. When I combine these together, the x's and the y's cancel on the left side, so I get a 0. The 2's cancel on the right side, and I get a 0. If all the letters drop out and a true statement remains, you're done doing your algebra. We just say there's infinitely many solutions. It's technically a few more problems to do. There's problems 49. 50 has infinitely many solutions, and problem 51. I'm going to take a vote. We can skip 51. If you want to try 51, go ahead, but you don't have to. I won't flash it back up here, and I'll go through your problem 49 with you, just so you can have something in the video that might help you if you're stuck with this. So my guess is that it has infinitely many solutions, but you can't tell by looking at it. First step, pair the middle with the other two. So the middle is negative x plus 2y minus 3z equals negative 4. Pair it with the top equation, x minus y minus z equal to 1. Then take that middle equation, negative x plus 2y minus 3z equals negative 4, and pair it with the bottom, 3x minus 2y minus 7z equal to 0. I said to drop out the y, so I'm going to drop out the y's. I'm going to drop out the y's from this first set by getting a positive and a negative 2y, multiplying the bottom by 2. The x is going to stay in negative x, which is really negative 1x in the top equation, and the whole top equation is not going to change at this point. Multiplying the bottom by 2, I go 2 times x and get 2x. 2 times minus y and get minus 2y. 2 times minus z and get minus 2z. 2 times 1 and get 2. Negative 1x plus 2x is positive 1x. Made the y's cancel. 3z and 2z are both negative. I'll combine them and get a negative 5z. Negative 4 and positive 2 combine to be a negative 2. Moving on to the next step, the y's are already set up to drop, so I'm just going to combine these how they sit. I'm going to go negative 1x plus 3x is 2x. Negative 3z minus 7z is minus 10z. Negative 4 and 0 give me a minus 4. Done with the second step. Now I'm going to stack these. X minus 5z equals negative 2 with 2x minus 10z equals negative 4. Doesn't matter what I try to drop out, both letters are going to drop out. I'm going to multiply the top by negative 2. It's going to cause both the x's and y's to cancel. I'm going to go negative 2 times x is negative 2x. Negative 2 times negative 5z is positive 10z. Negative 2 times negative 2 is positive 4. I'm going to leave the bottom equation, 2x minus 10z, that's equals positive 4, equals negative 4. On the left-hand side, both the x's and the z's cancel, I get a 0. On the right-hand side, 4 and negative 4 will also give me a 0. All the letters dropped out, I have a true statement, and I'm just going to say there's infinitely many solutions for my answer. If it was a false statement, I could say that there's no solution, or I can use the word inconsistent. And we won't get any more fancy than just that for the problems that have x, y's, and z's that have infinitely many solutions. All right, so that's the end of a really tedious section. The next section's even more tedious.